Hi, and welcome to our channel. My name is Daria, and I'm a part of the ExecPro research team. At ExecPro, we build software to test software. Do check out our website, execpro.com, if you want to learn more about us. Feel free to subscribe to this channel and hit the bell button if you want to see all the new videos, and we have plenty of those coming up. Today, we'll talk about testing the intelligence of AI. Let's start with defining what AI is. AI is machine behavior or function that exhibits the intelligence and behavior of humans. There are 7 widely accepted patterns in which AI can be implemented, and that means there are 7 different ways in which AI can substitute for a human being. And this is where it gets tricky. While we do trust qualified humans to make decisions in all kinds of mission-critical areas, we don't yet trust AI. Neither do we have mechanisms in place to ensure its efficient performance. Nonetheless, AI is obviously gaining traction, and governments all around the world are moving quickly to ensure that the legal framework remains up to date vis-à-vis the technology change and can indeed face the new challenges posed by AI. In fact, the regulatory bodies of many countries have already issued some form of official documentation on AI, be it prescriptive or descriptive in nature. Unequivocally, in the coming years, comprehensive AI regulation is expected to come to life. So, how do we make sure that AI does what it should and does it well? In its AI and Software Testing Foundation syllabus, the Alliance for Quality suggests that AI systems should be assessed pretty much like other traditional IT systems, that is, against a certain set of quality characteristics worked out by the QA industry. In addition to these characteristics, there are 3 criteria applicable specifically to AI systems, and these are the ability to learn, the ability to generalize, and trustworthiness. Regulators predominantly highlight the importance of human agency and oversight, technical safety, privacy and data governance, societal and environmental well-being, as well as accountability as key aspects of AI implementation. The ability to generalize is understood as the ability of the system to apply to different, previously unseen scenarios. It's as important a characteristic for an AI-based system as it is for any other non-deterministic system. In that, AI systems and complex platforms underpinning financial market infrastructures are very much alike. In AI systems, the ability to generalize is usually associated with variance. It refers to a model's sensitivity to specific sets of training data. However, traditional, meaning non-AI-based complex financial platforms, perform similarly. Being tested on a relatively small set of expected data, they experience failures when prompted with new data. Thus, the test approach focusing on the ability to generalize is equally applicable to traditional as well as AI systems. So there are a lot of similarities in how we approach quality assurance of complex non-deterministic systems, whether they are built with traditional technologies or AI-based ones. Testing activities in general can be affected by the same cognitive patterns as every other activity involving human judgment. There is, in fact, quite a number of cognitive biases affecting our decision-making in every area on a daily basis. Software testing is not an exception. When it comes to software engineering, biases are quite a serious impediment to begin with, but some types of systems under test tend to be more susceptible to specific ones. Let's look at the most common areas of application of AI to the financial services industry. We will see how well they align with the cognitive biases commonly manifesting themselves in quality assurance activities around these areas. Machine-readable news, or MRN, is one of these areas. Basically, MRN is data in an easy-to-consume format, which enables AI analyzers to define the sentiments behind the news pieces and extract information on new trading opportunities, market inefficiencies, event risks, etc. Testing of this type of AI systems would mean assessment of performance of an MRN analyzing algorithm, which largely depends on the underlying textual data. The media pieces tend to be full of fixed views and opinions, and the sentiments attributed to a particular topic in the markup process can be different from the author's actual intent. Hence, the main problem of the news media is its perception via the prism of confirmation bias. That is when a person interprets information in a way that affirms their prior beliefs and hypotheses. When testing AI-based systems, it's important to avoid confirmation bias as well. According to researchers, This bias is very common in testing as well as in software engineering in general. One of the most illustrative examples of the confirmation bias in software testing is the BDD approach. It's focused specifically on checking the lines in feature files rather than exploring all the possible paths of interaction with the system under test. Make sure you check out one of our latest white papers on testing the intelligence of AI. It contains all the scientific sources we relied on while preparing this research. You'll find the link in the description below. The next type of systems highly prone to biases are conversational assistant systems. These are a very common part of banking, insurance, and portfolio management services. Just a mere enumeration of the virtual assistants' names allows to suggest that the most common bias associated with testing chatbots would be anthropocentric bias. It's no secret that we tend to perceive objects and processes around us by analogy to humans. A vivid example is provided by the story published in the Washington Post. In the story, a colonel calls off the experiment with a mind-diffusing robot, being unable to watch, and I'm quoting, "the burned, scarred, and crippled machine drag itself forward on its last leg." He described the test as inhumane. Another example demonstrating this tendency is provided by Kate Darling's research about compassion towards robot dinosaurs. From the software testing perspective, this bias can obscure the understanding that what is evident for a human being can be a challenge for an AI system. With conversational agents, the most typical example is anaphoric relations. While for a human, it's easy to say what a pronoun refers to, for a machine, it would be easier to look at the closest word in the context. Another example is misspellings. A simple typo or an extra question mark can derail the otherwise successful dialogue with a virtual assistant. Thus, when testing chatbots, one should rethink the equivalence classes and significantly broaden the datasets containing user inputs. Another good example of an AI-based system is an adaptive smart order router or an algo trading platform. In high-volume, low-latency environment, it's often impossible to predict the exact outcome of a test scenario. The cognitive pattern which is likely to affect the QA activities around this type of systems is the so-called congruence bias. Congruence bias occurs due to over-reliance on direct testing of a given hypothesis while neglecting indirect testing. Congruence bias decreases the adoption of the advanced software testing techniques such as passive testing and post-transactional verification. These methods are much better suited for testing AI-based systems compared to more common active testing approaches. Moving on, pricing calculators are an example of systems which were using machine learning, big data, and non-deterministic methods long before they were adopted by the industry on a large scale. However, in some cases, like in mortgage-based structured products, it seems like the validation priorities might have been misplaced. There's a cognitive bias called Parkinson's law of triviality, also known as the bike shed effect. This is a tendency to give disproportionate weight to trivial issues. Parkinson provides the example of a fictional committee whose job was to approve the plans for a nuclear power plant. What the committee did instead was spend the majority of their time on discussions about relatively minor but easy-to-grasp issues, such as what materials to use for the staff's bike shed. They completely neglected the proposed design of the plant itself, which is far more important and a far more complex task. This behavior is very common when testing sophisticated systems. Another bias worth mentioning here is well studied in safety-critical systems. It's the automation bias. It doesn't just affect airplane cockpits, but also test automation, as the maturity of the software testing tools increases. Proper testing is important for monitoring systems as well. One of the approaches to overcome the automation bias is software testing tool diversity. When testing market surveillance systems, it's paramount not to rely on a single tool. Instead, one should consider using a toolset based on different technologies and approaches. These can be script-based tools, participant simulators, built-in custom alerts, and so on. The use cases around insurance claims management cover processing of images, text, and other unstructured data in order to predict an estimated cost of the loss. The role of an AI-based system suggests using historical data and comparing it to the predicted total loss cost to make a decision on the claim. While our experience does not yet cover software testing of this kind of systems, some lessons learned from the insurance industry can serve us well. Humans hate risk and ambiguity. This is where the zero-risk bias comes in. The zero-risk bias is a tendency to prefer the complete elimination of risk, even when alternative options produce a greater reduction in risk overall. From the software testing perspective, we frequently observe efforts to eliminate the risk in a specific module or around a new functionality without proper end-to-end testing of the whole system. Last but not least, we'll touch upon the illusion of control. The concern about the unpredictability of AI-based systems is ever increasing. Yet, humans tend to underestimate the complexity of the existing distributed, non-deterministic platforms. Thinking about complex distributed platforms built with traditional technologies as of less challenging compared to AI systems is an example of work of the illusion of control bias. It makes people happier and less stressed. Multiple studies prove it. Although less stress does not necessarily mean better performance. This concludes today's video. Remember to browse to the Testing the Intelligence of AI white paper on our website. You'll find that it contains the official list of references used in preparation for this video. Feel free to give us a thumbs up if you like the video. We do have a lot more interesting content for you, so don't hesitate to subscribe to the ExecPro channel. We'll review a ton more quality assurance and software development issues in the upcoming weeks. Remember to hit the bell button if you want to be the first to see the new content. We'll see you soon!